morning with you, Miss Yasmin, science teacher. We are going to cover Unit 1, Lesson 2, Wave Motion. Slide number 2. The wave. The disturbance that propagate and transfer energy in the direction of propagation. The wave motion. The motion which is produced as a result of vibration of the medium. Here's slide number 3. Types of waves. What are the types of waves? The direction of the vibration of the medium and the ability to propagate and transfer energy. Here we have the direction of the vibration of the medium, transverse wave and longitudinal wave. In the transverse wave we have crest and trough, and in the longitudinal wave we are going to take compression and rarefaction. The ability to propagate and transfer energy. We have mechanical waves that need medium and electromagnetic waves that doesn't need medium. Slide number 4. Transverse wave. It is a disturbance in which a particle of the medium vibrate perpendicular to the direction of the wave propagation as shown here in the figure. It is called transverse wave. Slide number 5. It consists of crest and trough. What is the crest? It is the highest point of the particle of the medium. What is the trough? It is the lowest point of the medium. As shown here in the figure, we can see the crest, it is the highest point, and down we can see the trough. Slide number 6. Give reason. Water wave are transverse wave because water vibrate perpendicular to the direction of the wave propagation. Here we have a figure to show the transverse wave. Here we can see that the water wave are transverse wave. It moves up and down. So the up and down motion of the rope here is perpendicular. It is like to the water wave. Slide number 7. Longitudinal wave. It is a disturbance in which a particle of the medium vibrate along the direction of the wave propagation. So here in the longitudinal wave, we can see compression and rarefaction. Slide number 8. What's meant by compression and what's meant by rarefaction? Compression, it is the area of the longitudinal wave that high density and pressure. Rarefaction, it is the area of the longitudinal wave that has low density and pressure. So here we can see compression, area of longitudinal wave high density, and rarefaction low density. Slide number 9. Give reason. Sound wave are longitudinal wave because the particle of the medium vibrate along the direction of the wave in sound wave. Slide number 10. Note, crest is equal to the compression in the longitudinal wave in the transverse wave, but trough equal rarefaction in the longitudinal wave in the transverse wave. So here as shown in the figure, we can see the compression and the rarefaction. The compression high and the rarefaction is low. And here we can see the crest and the trough. The crest equal compression and the trough equal rarefaction. Slide number 11. Life application in the jacuzzi. The idea of work. Water move in the form of circular waves. What are the uses of the jacuzzi? It is used to treat pain and cramps by using hot water, nervous tension by using cold water. So it is used hot water for pains and cold water for nervous tension. Slide number 12. Now we are going to make comparison between electromagnetic wave and mechanical wave. Electromagnetic waves, they are type of wave which don't need medium to propagate. But the mechanical waves, they are type of wave which need medium to propagate. So the electromagnetic wave, it propagates through vacuum. But the mechanical wave, it can't propagate through vacuum. Here the velocity or the speed of the electromagnetic wave equals 3 by 10 power 8 meter per second. Example for the electromagnetic wave like the light wave and the radio wave and the infrared wave. Mechanical wave, example here, water wave and sound wave. In the mechanical waves, they are transverse or longitudinal wave. Their velocity is less than the velocity of the electromagnetic wave. And we said that the velocity of the electromagnetic wave equals 3 by 10 power 8 meter per second. Slide number 13. Give reason. We can't hear the sound of solar explosion, but we can see the light which come. Because the sound wave is mechanical wave which need medium, but the light wave is electromagnetic wave which doesn't need medium to propagate. Slide number 14. The wavelength of the transverse wave. It is the distance between two successive crests or trough, and the unit here is meter. The wavelength of the longitudinal wave. It is between two successive distance compression or rarefaction. The wavelengths equal distance covered by the wave per number of waves. Slide number 15. The amplitude of the wave. What's meant by the amplitude? It is the maximum displacement of the medium particle away from the position. And here also the unit is meter. So the amplitude equal the distance between crest and trough over 2. Slide number 16. We can see here that the amplitude and the wavelength, and we can see the crest and the trough. Here we can see the compression and the rarefaction, high density and low density. And wavelength, it is the distance between two compression or two rarefaction. Slide number 17. The wave velocity, V. The distance covered by wave in 1 second. Velocity equal distance covered by wave, and the unit is meter per unit time, which is second. So the unit equal meter per second. Slide number 18. Wave frequency, and the symbol of frequency is F. What is the wave frequency? It is number of wave produced in 1 second. So frequency equal number of wave over time, so it is equal 1 over time. And the wavelength equal distance covered by the wave over number of waves. Slide number 19. The distance covered by equal number of wave in 1 second multiply the wavelength, and the velocity equal frequency by wavelength. Slide number 20. Here we have a problem. A longitudinal wave is produced by spiral spring where the distance between first and fourth is 18 centimeters. Find the value, find the wave velocity of the frequency of such wave is 20 h. So here we have compression and rarefaction, and we have longitudinal wave. Slide number 21. The first and fourth rarefaction, it means equals 3 waves. So the wave velocity equal R multiply F. R here equal distance covered by the wave over number of waves. So R equal 18 over 3 equals 6 centimeter equal 0.06 centimeter. So the velocity equal R multiply F equal 0.06 multiply 20 equal 10 meter per second. Slide number 21 here, we have the velocity equal R multiply F equal 0.06 multiply 20 equal 102 meter per second. Thank you.